The binomial expansion of 1 plus x whole raised power n is equal to 1 plus n choose 1 times x plus n choose 2 times x square plus n choose 3 times x cube plus and so on, and the last term is x raised to the power n. Let's call this result 1. The binomial expansion of 1 plus x raised to the power minus 1 is equal to 1 minus x plus x square minus x cube plus and so on, plus minus raised to the power r times x raised to the power r plus minus raised to the power r plus 1 times x raised to the power r plus 1 plus minus raised to the power r plus 2 times x raised to the power r plus 2 plus and so on, plus minus raised to the power n x raised to the power n plus and so on. Now differentiate this expression with respect to x on both sides. On the left hand side we get minus of 1 plus x raised to the power minus 2, and this is equal to the derivative of the right hand side, which is minus 1 plus 2x minus 3x square plus and so on, plus minus raised to the power r times x raised to the power r minus 1 plus minus raised to the power r plus 1 times r plus 1 times x raised to the power r plus and so on, plus minus raised to the power n times x raised to the power n minus 1 plus and so on. Now take the derivative of both sides with respect to x again. On the left hand side we have minus of minus 2 times 1 plus x raised to the power minus 3, and the derivative of the right hand side is equal to 1 times 2 minus 2 times 3 times x plus 3 times 4 times x square plus and so on, plus minus raised to the power r times r minus 1 times x raised to the power r minus 2 plus minus raised to the power r plus 1 times r plus 1 times x raised to the power r minus 1 plus minus raised to the power r plus 2 times r plus 1 times r plus 2 times x raised to the power r plus and so on, plus minus raised to the power n times n minus 1 times x raised to the power n minus 2 plus and so on. Let's call this result 2. Now multiplying results 1 and 2, on the left hand side we get 2 times 1 plus x raised to the power n minus 3, and on the right hand side we have 1 plus n choose 1 times x plus n choose 2 times x square plus and so on, plus n choose r minus 2 times x raised to the power r minus 2 plus n choose r minus 1 times x raised to the power r minus 1 plus n choose r times x raised to the power r plus and so on, plus x raised to the power n multiplied by, in brackets, 1 times 2 minus 2 times 3 times x plus 3 times 4 times x square plus and so on, plus minus raised to the power r plus 1 times r plus 1 times x raised to the power r minus 1 plus minus raised to the power r plus 2 times r plus 1 times r plus 2 times x raised to the power r plus and so on, plus minus raised to the power n times n minus 1 times x raised to the power n minus 2 plus and so on. Let's call this result 3. Now the coefficient of x raised to the power r on the left hand side of result 3 is equal to 2 times n minus 3 choose r, and the coefficient of x raised to the power r on the right hand side of equation 3 is obtained by multiplying the constant term in the second bracket with the coefficient of x raised to the power r in the first bracket, resulting in 1 times 2 times n choose r plus Multiplying the coefficient of x in the second bracket with the coefficient of x raised power r minus 1 in the first bracket, resulting in minus 2 times 3 times n choose r minus 1, plus and so on. And the last term is obtained by multiplying the constant term in the first bracket with the coefficient of x raised power r in the second bracket, resulting in minus raised power r plus 2 times r plus 1 times r plus 2. Now equating the coefficients of x raised to power r across the left hand side and the right hand side of equation 3, we get 1 times 2 times n choose r minus 2 times 3 times n choose r minus 1 plus 3 times 4 times n choose r minus 2 plus and so on, plus minus raised power r times r plus 1 times r plus 2 is equal to 2 times n minus 3 choose r, which is the required result.